Good morning students. Today we are going to next lecture number 6, Introduction to Probability. The concept of probability is fundamental. Any field, whether you call it statistics or analytics or you data science, everywhere. Because if you look at some of the book titles of the statistics or analytics, it will come with probability and statistics. Because the concept of probability and statistics is, you cannot separate it, because always it go together. Because in the concept of statistics, since we are taking sampling, we are predicting about the populations. Whatever we say with the help of sampling, we have to attach always some probability, because it cannot be 100% sure that whatever you say with the help of sample will be exactly, you cannot predict it. So, once there is a prediction comes, then you have to attach some probability to that. Okay. Today you will see it is an introduction to probability. I am not going to teach in detail about that one. What are the ideas which are important for us, only that I am going to teach. So, the lecture objective is to comprehend the different way of assigning probability, understand and apply marginal, union, joint and conditional probabilities, and solving problem using laws of probability, including law of addition, multiplication and conditional probability, and using very important theorem, that is the Bayes rule, that to revise the probability at the end. These are my lecture objectives. So, we will go the definition of the probability. The probability is the numerical measure of likelihood that an event will occur. The probability of any event must be in between 0 and 1, inclusively 0 to 1 for any event A. The sum of the probability of all mutually exclusive, collectively exhaustive event is 1. Later I will explain what it means by mutually exclusive, collectively exhaustive events. So, always the probability of summation of probability will be equal to 1. So, for example, probability A plus probability B and probability C equal to 1. Here A, B and C are mutually exclusive and collective events. So, this is the range of probability. You see that if it is any impossible event, the probability value is 0. If it is a certain event, the probability is 1. If it is a 50% chance, the probability is 0.5. So, the point here is, it is the probability lies between 0 to 1. Okay. The method of assigning probability, there are 3 methods. One is the classical method of assigning probability, rules and laws, then relative frequency of occurrence, that is the cumulative historical data, and subjective probability, that is a personal intuition or reasoning. By using these 3 methods, let us see how to find out the probability. First one is a classical probability. The number of outcomes leading to an event divided by the total number of outcomes possible is a classical probability. Each outcome is equally likely, that is equal chance of getting different outcome. So, it is determined a priori, that is before performing the experiment we know what are the outcome is going to come. Suppose if you toss a coin, there are 2 possibilities, head or tail. In advance we know what are the possible outcomes. It is applicable to games of chance. The objective is everyone correctly using the method assign an identical probability, because what is happening here, using classical probability, that everyone will get the same answer for the problems, because we know in advance what are the possible outcomes. So, mathematically the probability of E is n of E divided by capital N, where the capital N is the total number of outcomes, n of E is the number of outcomes in E. Okay. Then relative frequency probability. It is based on the historical data, because the another name for relative frequency is the probability. It is computed after performing the experiment, number of items an event occurred divided by number of trials, nothing but frequency then divided by sum of frequency. Here also everyone correctly using this method assign as identical probability, because everything is already known to you. So, the same formula, probability E is n of E divided by n of, where a small n E is number of outcomes, capital N is total number of trials. Then subjective probability, it comes from a person's intuitions or reasoning. Subjective means different individuals may correctly assign different numerical probabilities to the same event. It is the degree of belief. Sometimes subjective probability is useful. For example, if you introduce a new product, suppose if you want to know the probability of success of that new product, so we can ask an expert that what is the probability of success. Even it is a new movie or new project, what is the probability of success? It is based on the intuition or based on the experience of the person, he can give some probability of success or failure. For example, site select decisions for sporting events, for example in cricket, what is how much possibility of one team to win, these are intuitive probability. In this course that there are certain terminology with respect to probability, you have to know, it is very fundamentals, even though you might have studied in our previous classes, it is just to recollect it. What is the experiment, we will see what is the experiment, event, elementary event, sample space, union and intersections, mutually exclusive events, independent events, collectively exhaustive events, complementary events. These are some terms, we will revise this. One is we say what is experiment, trial, elementary event and event. Experiment, a process that produces outcomes is experiment. So, there are more than one possible outcome is there, only one outcome per trial. Okay. What is a trial? One repetition of process is a trial. What is the elementary event? Event that cannot be decomposed or broken down into other events, that is elementary events. Then what is the event? An outcome of an experiment may be an elementary event, may be an aggregate of elementary event, usually represented by uppercase letters, for example AE, that is notation for event. We will look at this example. If you look at the table, there are some towns population is given, there are 4 families there, family A, B, C, D. We have asked 2 questions, children's in household, whether do you have children or not. Say family A, yes, then we asked number of automobiles, how many number of automobiles you have, 3. B, they have children, they have 2 automobile. For the help of this table, we will try to understand what is the experiment. For example, randomly select without replacement 2 families from the residents of the town. For example, randomly we can select. So, elementary event, for example, the sample includes family A and C, randomly we have selected. So, event, each family in the sample has children in the household. The sample families own a total of 4 automobiles. So, these are particular events. For example, for event, each family in the sample has children in the household. For example, A is one event, D is another event. For example, the sample families own a total number of 4 automobiles. For example, A and C, they have 4 automobiles. B and D, they have 4 automobiles. A and D, they have more than 4 automobiles. This is the example of event. Then what is a sample space? The set of all elementary events for an experiment is called a sample space. Suppose if you roll a die, there are, you can get 1, 2, 3, 4, 5, 6, these are the sample space. There are different methods for describing the sample space. One is listing, tree diagram, set builder notation and Venn diagram. We will see what is that. See, this is listing, experiment, randomly select without replacement 2 families from the residents of the town. So, each ordered pair in the sample space is elementary event, for example, D, C. So, what is the different possibility? Look at this table, AB, AC, AD, BC, BA, BC, BD, CA, CB, CD. So, this is the listing the sample space. What is that? We have to select 2 families from the residents. So, here we are doing without replacement. Without replacement means, suppose A, it will not be again A. If it is B, it will not be again B. Once A is taken, we are not selecting another A. So, without replacement. The same thing, the another way to express the sample spaces with the help of tree diagram. This tree diagram is very useful and easy to understand. For example, A, B, C, D, there are 4 families. We can have combination AB. We can combination AC, AD, BA, BC, BD, CA, CB, CD, DA, DB, DC. So, this is the easy way, these are different sample space, because tree diagram is easy to understand. Okay. Now, the set notation for random sample of 2 families. So, S equal to open bracket x comma y, x is the family selected on the first draw and y is the family selected on the second draw. It is the concise description of large sample spaces. In mathematics they use this kind of notations. You see the sample space can be shown in terms of Venn diagram. So, this was a list of sample space, see that this is a different dot express different sample space. Then we will go to the another concept, union of sets. The union of two sets contains an instance of each element of the two sets. For example, x is 1 4 7 9 one set, y is another set 2 3 4 5 6. So, if we want to know x union y, just we have to combine 1 2 3 4 5 6 7 8 9. Similarly, if you look at the Venn diagram, x is 1, y is 1, if you want to know union, combining both the events. Another example, say C, IBM, DEC, Apple, that is the C set, there is another set F, Apple, grape, lime. Suppose we want to know union of set C and F, so we have to take IBM, DEC, Apple. Apple is coming in both the sets, we are taking only one, grape, lime. This is the union. We will go for intersection. Suppose x equal to 1 4 7 9 one set, y is 2 3 4 5 6. If you want to know common, intersection is two sets contain only those elements common. So, here the 4 is common in x and y. So, x intersection y is 4. For example, C and F, in C we have IBM, DEC, Apple, in F we have Apple, grape, lime. The C intersection F, that is a common thing between set C and F is Apple. So, this one saying this portion says our intersection. Then we will go for mutually exclusive events. Event with no common outcomes is called mutually exclusive events. Occurrence of one event precludes the occurrence of other event. For example, C, BM, DEC, Apple, F is grape, lime. So, C intersection there is no common thing. So, that is why it is a null set. Similarly, X 1 7 9, Y is 2 3 4 5 6, X intersection Y there is no common set. Look at the Venn diagram, there is no common thing. So, X intersection Y is 0, these two sets are not overlapping. So, it is called mutually exclusive events. Another example for this, when we toss a coin, there is a two possibility to get the outcome, one may be head or tail, it cannot have both, that is why both events are mutually exclusive event. Then independent events. So, occurrence of one event does not affect the occurrence or non-occurrence of other event is called independent event. The conditional probability of x given y is equal to the marginal probability of x. The conditional probability of y given x is equal to the marginal probability. The one way we will do one small problem on this. One way to test the independent event is, suppose the p of x given y equal to p of x, and if p of y given x is p of y, then event x and y are called independent events. We will go in detail after some time with the help of an example. Okay, collectively exhaustive event. It contains all elementary events for an experiment. Suppose E1, E2, E3, sample space with 3 collectively exhaustive events. Suppose if you roll a die, all possible outcome 1, 2, 3, 4, 5, 6, that is collectively exhaustive events. Then complementary events, and elementary events not in the A or is its complementary event. You see that? If the P of A is there, which is not there, that is A dash, that is called complementary. So, P of A dash is equal to 1 minus P of A. Then counting the possibilities, because in probabilities many times different combinations may come, these rules may be very useful for counting different possibilities. One rule is MN rule, second one is sampling from a population with replacement, second one is sampling from a population without replacement. We will go for MN rule. If an operation can be done M ways and a second operation can be done N ways, then there are Mn ways for the two operations to occur in order. The rule is easily can be extended to k stages with a number of ways equal to, if there are k stages n1, n2, n3, just simply we have to multiply this. For example, toss 2 coins, the total number of sample event is 2 multiplied by 2 equal to 4, because in the first coin you may get 2 possibility, second coin you may get another 2 possibility. So, the total is 4 possibilities. Suppose you see that another example of sampling from a population with replacement. One example is a tray contains 1000 individual tax returns. If 3 returns are randomly selected with replacement from the tray, how many possible samples are there? So, every time you are going for a 3 trial, trial 1, trial 2, trial 3. In each trial there are 1000 possibilities because you can choose 1 from 1000. So, first trial 1000, second trial 1000, third trial 1000. When you multiply this, this is 1000 million possibilities there with replacement. In case if you go without replacement, the same thing, because without replacement what will happen, the sample size will decrease. A tray contains 1000 individual tax returns. If 3 returns are randomly selected without replacement from the tray, how many possible samples are there? So, that is a NCN, that is n factorial divided by n factorial multiplied by n minus n factorial, that is 1000 factorial divided by 3, 1000 minus 3 factorial, it is 1066,160,000. You see the previously with replacement, I am going to previous slide, with replacement it is a 1000 million, now it is only 166 million because we are going for without replacement. There are different types of probability, say we can call it as a marginal probability, union probability, joint probability and conditional probability. Then what is the notation? Marginal probability is simple one probability P of x. So, how it is expressed in terms of Venn diagram? See this one, so marginal probability. Then union probability, it is a x union y, the probability of x or y counting. Then joint probability or common probability, the probability of x and y occurring together, the middle portions. Then conditional probability, the probability of x occurring given that y has occurred. Here there are two events, the probability of the outcome of x is depending upon the outcome of y. So, we have to read it probability of x given that y has occurred. So, this is the Venn diagram notation for expressing the conditional probability. Then we will go for general law of addition. So, P of x union y equal to P of x plus P of y minus P of x intersection y. We will take one small example. From that example we will understand the concept of probabilities. A company is going for improving the productivity of that particular unit. They are coming with a new design. One design is layout design, for example layout design. One design will reduce the noise, that is one option. There is a second design that will give you more storage space. So, we are going to ask from the employees what kind out of these two design, which design will improve the productivity. Okay. You see the problem. A company conducted a survey for the American Society of Interior Design, in which workers were asked which changes in the office design would increase productivity. There are two designs there. One is the one design will reduce the noise, another design will improve the storage space. The respondents were allowed to answer more than one type of design changes. So, this table shows the outcome. So, 70% of the people have responded that reducing noise would increase the productivity. 67% of the respondents have responded that more storage space would increase the productivity. That is a two design. So, we are asking from the respondent which design will improve the productivity. Suppose if one of the survey respondents were randomly selected and asked what office design change would increase workers' productivity. Otherwise, what is the probability that this person would select reducing noise or a design which is helpful for providing more storage space? Out of this, that means out of two options. So, let n represents the event reducing noise, that means he has chosen that design. S represents the event more storage space, yes, that is another option. The probability of person responding to n or S can be symbolized statistically as a union probability by using law of addition, that is a P of n union S. So, see that P of n union S is, because we know that as per the formula P of n union S is P of n plus P of S minus P of n intersection S. So, the P of n is 70%, P of S is 67 percentage. Those who have told yes for both the designs is 0.56. So, when you substitute these values in the formula, so we are getting 0.81, that is 81 percentage of the people have told both the designs will increase the productivity. What we had solved with the help of Venn diagram in the previous slide can be solved with the help of contingency table. This contingency table is so helpful. Just we have to make a table. For example, in rows I have taken noise reduction. The noise reduction, say 70% of people have told yes. So, remaining 30 might have told no, 70-30. In the column I have taken increasing storage space design. In that you see 67 percentage total, they have told that increasing storage space would increase the productivity. So, remaining 33 might have told no. So, the 0.56 is intersection. People have told both yes for both the design, that is for noise reduction and increasing storage space. So, once if you know this 0.56, the remaining things you can subtract it. 0.7, 0 minus 0.56 is 0.14, that is those who are told no to storage space and yes to noise reduction. Then if you subtract from 0.67, you will get 0.11. 0.33 minus 0.14, you will get 0.19. So, from this table we can read a lot of informations. Whatever it has, this is for example event A, A1, A2, event B1, B2, it is in the rows. You see that it is in the columns. Whatever cell inside the cell, this portion is called join probabilities, P of A1 intersection B1. Whatever it is the extreme side of the table, see that this is called marginal probabilities. This is the notation that traditionally they follow. Whatever the inside the cell, it is a combination of both the event, that is it is the joint probabilities. Whatever extreme at end, it is a marginal probability, extreme side of the table. Okay. The same thing, suppose if you want to know the same answer with the help of this contingency table, we want to know how much percentage of the people who have agreed for both the design, that is n and s. So, P of n plus P of s minus P of n and s. So, this value directly we can read it from the table. So, P of n is 0.7 plus P of s is 0.67 minus P of n intersection s is 0.56. So, when you do that, we are getting 0.81. Then we will go for conditional probability. The probability of n is 0.70. Those who are agreed both the design n and s is 0.56. Suppose if you want to know P of s given n equal to P of n intersection s divided by P of n. So, this value I will explain this conditional probability in detail later, but now you take this one. So, P of n intersection s from the previous table you can find out it is a 0.56. You can look at the Venn diagram also. P of n is 0.7, when you substitute you are getting 0.8. Okay. The same office design problem, you see that there is another conditional probability P of n dash given y, that means those who are told no to noise reduction, but they have agreed for storage design. So, this is the conditional probability. So, we have to multiply P of n dash intersection s divided by P of s. N dash intersection s is this point, because n no, yes, this is 0.11 divided by P of s is 0.67, that is equal to 0.164. We will take another small problem. We will explain the concept of probabilities with the help of the problem. A company data revealed that 155 employees worked on 4 type of positions. The table is shown in the next slide. Raw value of matrix, also called contingency table, with the frequency counts of each category and subtotals and totals containing breakdown of these employees by type of position and by sex. You see that, look at this table. In rows, the type of position they hold in their organization, whether they are working in a managerial position, professional or technical or clerical. In the column, sex, whether male or female. you see the intersection of managerial and male 8, that represents both, that is who are managerial, who are working in a managerial position, at the same time they are male. So, that is our join values, here the only count, join counts. The extreme right or the bottom of the table we have given the total counts. Now, if an employee of the company is selected randomly, what is the probability that the employee is female or professional worker? So, what we have to do? So, we are going to find out P of F in union P, that is a P of F plus P of P minus P of F intersection P. So, P of F is, when you go to the previous one, P of F is, so when you divide 55 divided by 155, you will get 0.335. P of P is, when you divide 44 divided by 155, you will get 0.824 minus P of F intersection P, that is F intersection P, 13 divided by 155, you will get 0.084, that equal to 0.55. There is another problem. Shown here are the raw value matrix and corresponding probability matrix of the result of a national survey of 200 executives who were asked to identify geographic location of their company and their company's industry type. The executives were only allowed to select one location and one industry type, because it is not possible same person working different location, different industries, because one person can work only one type of industry. We will conclude that in this session we have seen different types of probability, how to assign probability, and different counting rules, MN rules with replacement, without replacement, and different terms which are frequently we are going to use in this course, that is the event, joint probability, marginal probability, and so on. Then we have taken one sample problem. With the help of sample problem, we have seen how to find out union of two events, that is a joint probability P of A union B, then intersection P of A intersection B, then how to find out the marginal probability, then how to find out the conditional probability. With that we will close. We will continue in the next lecture. Thank you very much.